Hi guys, so this is going to be the video of me doing the demo that I did in class on Monday, November 23rd or Tuesday, the 24th. So in case you guys missed it or you didn't get to see all of it for whatever reason during class, you can watch it here now. I'm going to repeat the entire thing and I'm going to go over this chart. Okay. So first things first, I'll have the camera kind of angled down at the table a lot, so you won't really get to see this too much, but I'll make sure that I, periodically lift up the camera and point to kind of what I'm talking about and what I'm demoing and what it represents so that you guys get that feedback and you can fill in that section of your table. So just to clarify, you're filling out the section called Introduction, and it's like a table that kind of looks like this that says physical property and method of separation on your table, and you're gonna put the 4 different physical properties that we investigate here, and then examples of each kind of method to separate the mixture based on that physical property. Okay, so let's get started. All right, I'm gonna aim the camera angle down so that you guys can see exactly what I'm doing. And I'm gonna grab my supplies. So the first thing I'm going to do is I'm going to mix some salt with some play sand. So I'm gonna make a mixture, and then I'm gonna try to separate that mixture. Okay, so I'm gonna make the mixture first. So I have a little bit of salt. I'm just gonna mix some dry salt. Actually, this is not a dry test tube, so I'm gonna use a different one. Okay, we'll use this one. If I don't have a dry test tube, the sand and stuff will stick. So I'm just gonna put a little tiny bit of salt. See, I'm just putting a little bit of salt. You can kind of see it in there. And then I'm gonna put a little bit of play sand. I'm gonna use my scoopula to get that. So we're just gonna put a little bit in there, about the equivalent amount of salt that I have in there. So we have equal parts. Okay, so now you can see I have 2 different things in there. The sand is a little bit more yellow. So the sand is on this side right now. It's like right here. And the salt is on this side. And the salt is a little more white. So I'm gonna mix it up pretty good so I can't just separate it. Okay, now as you can see, it's pretty separated. You can't really tell the difference between them. So let's try to separate it. All right, the first thing I can tell you is that salt is smaller. So salt has smaller crystals than sand, okay? So sand has bigger crystals. So with that being said, because I know that, we can try to sift it out using this. Okay, so this, I don't know if you can see, but it is a little screen, so it'll enable us to sift different size particles. And you guys have done this before, so it's kind of like when you take your spaghetti with your water, your boiling water, and you dump it in a colander, one of those like bowls with the holes, bowls with the holes, that rhymed. But so it's kind of like that where you're sifting out based on size. So let's try to do that first to see if we can do it the easy way. So I'm going to go ahead and pour this through. And it looks like it all just went straight through. So we still have a mixture of sand and salt there. So that did not work effectively. So now what we have to do is we have to mix this with water and do it another way because that did not work. Okay, so I'm gonna get that out of my way. So we know another thing about salt and sand. So first of all, think about um, when you have, water boiling and you put salt in the boiling water, it kind of disappears, right? That's because the salt will dissolve in the boiling water because the water likes to pull apart salt so that you can't see it anymore because it gets so small. Now think about the beach, okay? So what do you stand on? You stand on sand at the beach, right? Um, what's underneath the water? Like what's on the floor of the lake? Sand, right? So do you think that sand will dissolve in water? No. Okay, because if sand were to dissolve in water, we would have no beaches because there would be nothing but, well, I guess we could stand on rocks at the bottom of the lake, but it'd be mildly uncomfortable. But so we don't. We stand on sand that's below the lake, so we know that sand does not go away when mixed with water. Okay? So because of that information, I'm going to mix this mixture with a little bit of water and dissolve all the salt. And when that happens, the salt should go away, but the sand should remain. And I'm just adding some distilled water. That should be enough. I'm going to stir it up with my stir rod. It's kind of an awful sound. Okay, so now I'm going to show this to you. You can see this. You can see that there's significantly less solid in there. That's because the salt is now gone, so we can't see the salt anymore. So all we're seeing in there is sand. Okay, so sand is at the bottom. Now, how do we separate it without letting any sand escape or any water? Well, we can do what's called filtration. And so right here, I have a little filtration apparatus. So I have a funnel and I have what's called a clay triangle. And this is just over a beaker, okay? And so the reason for the clay triangle is so I can set the funnel in there and the funnel won't hit the bottom, okay? Because if the funnel hits the bottom, then the water won't come out. So we want to make sure that does not happen. Now, when we're doing filtration, we have to use filter paper. And so basically, this is what filter paper looks like. It's like a circle. And it feels like pretty normal paper. But the thing is, it's kind of see-through. So I don't know if you can see it, but it's kind of thin compared to like regular writing paper. And that's because small particles can actually go through this if they're small enough. So for example, water can go through this. And when dissolved in water, salt can go through this. Because remember, water breaks up salt into very tiny pieces. Okay, so when that happens, when you dissolve salt in water, it will actually go through the filtered paper. But guess what's too big to go through the filter paper? Sand, right? Sand is too big to go through the filter paper. So when we use the filter paper to separate this, sand will stay on the filter paper and the water will pass through it with the salt. Okay, so let me fold this. So you first fold it like a taco. This is how you use it. So you fold like a taco first. Looks like a tiny little taco. And then you fold it again so that it's in fourths. So once it's folded, you'll find that you have so when you fold it like this, you'll find you have little pockets. And so I'm just going to take one of those pockets and open this up and see it looks like a little cone. So I'm going to put this in my funnel, but look what happens. It won't stay. So what we have to do is we actually have to take a little bit of distilled water and just kind of put it in there so it stays. Now it stays. All right, so the next thing we're going to do is we're going to pour our solution, which is this, in here to separate the sand from the salt water. But the thing you cannot do is you cannot go over the filter paper, okay? So you can't go over the filter paper, or else the solution will go over the side and then contaminate the water down here, and then it won't be filtered, right? So you kind of have to be patient with this. It takes kind of a long time. So you have to add it gradually. And do you see it dripping? So you can see it is coming out, and it's coming out clear, so there's no sand in there. All right, and we have to keep adding every couple minutes when this goes down a little bit. Okay, so while we're waiting for that to finish, I'm gonna go get the stuff to do the next demo. Okay, so now you can see I've added a couple things to my desk and I've moved the filtering apparatus out of the way. So I added a hot plate, and right now it's not hot. I have it turned off and unplugged. So I have a hot plate, which I'm going to use to heat up this water once it's done filtering, so that after we filter out the sand, so after we get rid of the sand from this water, we have salt water, right? And then we can actually continue to separate this mixture further by removing the salt from the water. So I'm gonna do that as soon as this is done filtering. Okay. But in the meantime, I do have 3 beakers, and this one is filled with plain distilled water. This one is filled with ethyl alcohol, and this one is filled with ethyl alcohol. And so the next thing we're going to do, is it's called chromatography. So paper chromatography. Okay, and basically what paper chromatography is it can separate the pigments within ink. So pigment is a word that just means colors. And there's ink inside markers. So markers like Crayola or like Sharpie. And so we're going to test to see if these markers are pure black or if there are a mixture of different colors. And if they're a mixture of different colors, this will allow us to see the different colors. Okay? So how this works is this is also a separation based on size. Okay? So what happens is I'm gonna draw a line at the bottom of this paper. And then I'm going to dip this paper in ethyl alcohol and leave it there. And what's gonna happen is the ethyl alcohol, or in this case, water, it will travel up the paper and it'll take the ink with it. But when it takes the ink with it, only colors of a certain size can go up certain like lengths, okay? So for example, if I have a strip of, I don't know, one color and the ethyl alcohol takes it up, some pigments will be bigger in particle size than other pigments. And those pigments, if they're bigger, will get stuck like down here. And the smaller pigments will not get stuck because they're tiny and they can move faster. And they'll end up here, so farther up the thing, because they can move faster and farther because they're tinier. Okay, so that's pretty much what's going to go on here. So I'm going to go ahead and draw my lines, and I'll kind of show you how I'm going to do that. So I'm just going to take this and draw a nice line. This is a Crayola marker, so I'm going to do that. Now I'm going to do another Crayola. Okay, now I have 2 lines, and now I'm going to use Sharpie for the last one, just to compare it. Okay, now I have a Sharpie. So now I don't want to get these confused, so I'm going to label them, and I'm going to label them with regular pencil because graphite, which is what the pencil is made of, will not travel up the paper. So I'm just going to put a C for Crayola. as in Crayola marker, okay? So now the next thing, since I have 2 Crayolas, I'm gonna put one in water, and that's gonna be my control. And I'm gonna put one in ethyl alcohol, and then I'm gonna put the other in ethyl alcohol to compare the Sharpie, okay? So how you do that is you bend this, you bend it so you can get it to dangle over a pencil like this, and just dip the tip of the paper in the water or ethyl alcohol, okay? So it's gonna look like this. So I just dipped the paper in the water, so the ink is not submerged, because if the ink's submerged, it'll just wash away. But the water will just travel up the paper. Same thing with ethyl alcohol. So I'm gonna again fold this. And I'm gonna make sure that I'm not submerging the ink, just dipping it. Perfect. So again, I'm not submerging, just dipping it. And the ethyl alcohol is gonna move the page. I'm gonna do the same thing with my Sharpie in the ethyl alcohol. Again, just dip it. So we're gonna leave that and see what happens with those guys, okay? In the meantime, I'm almost done filtering this out, so I'm just gonna make sure I can get everything. And that's how you make sure you get everything out. You use a squirt bottle and you kind of like rinse it out. Okay, so now I'm gonna wait for this to finish. We can boil that water. And I'm going to set these guys over here. So again, that's Sharpie in ethyl alcohol. This is Crayola in ethyl alcohol. And that is Crayola in water. All right, now I'm gonna get us set up for the last demo before we boil this. And I will update you on what these guys looked like down here. So while I had the video paused, this funnel actually finished filtering. So I'll show you. So you can actually see the sand in the bottom of there. And so if I actually take out the filter paper, you can actually see the sand in the bottom of the filter paper. So I'm gonna take it out.
How are you?
And so here's the sand after I unwrapped it. You can kind of see it. So it's just a clump of sand. It's a little bit of wetness. But yeah, that's what we filtered out of the water. So I'm gonna go ahead and throw that away. And now we can actually take this water and evaporate it. And so when we evaporate this water, all that's left will be salt. Okay, so you can't really see the salt right now, but after I evaporate it, you'll be able to. So I'm gonna put it on my hot plate. And I'm gonna plug my hot plate in, or else it won't work. And then I'm going to turn it on, and I will come back to you guys when it's boiling, because I'm not gonna make you guys sit here and watch water boil. Okay, so this is our last demonstration for this. So I have a mixture of sulfur and iron. The sulfur is the yellow stuff and the iron is the darker stuff. So we have a mixture here. And so just to show you guys like if this will work or not, I'm again gonna use the sifter. So the thing that sifts, the little wire thing, to see if I can separate it based on shape. Or not shape, size, I'm sorry. See if I can get any particles. So for the most part, no, it did not work. You can still see some sulfur there with the iron. So it did not work, it was not effective. So we had to try another way. So I happen to know something about sulfur and iron. So I know that sulfur is not magnetic, but I know that iron is. So since iron is magnetic, I can actually wave a magnet over the mixture, and the iron should stick to the magnet and should leave behind the sulfur. So I'm going to come to the front so you guys can actually see what I'm doing. And so I'm going to hold this, and I'm going to wave this magnet over it. And you see how the iron is attaching itself to the magnet? See that? See all the iron that's attached to the magnet. So that shows you that iron is magnetic. So I'm going to take this off. And the reason why the iron or the magnet's in a bag is because if you attach the iron to the metal magnet, it's really hard to get off because it's really strong. So again, I'm going to do the rest of this. So I'm just going to So again, I'm just gonna and look. So now it's just yellow powder. Okay, so we successfully separated the sulfur from the iron using a magnet. Okay, oops, I missed a spot. But yeah, for the most part, it worked very effectively. So now it's time to check up on our other experiments. So just so you know, the water is boiling on the hot plate. The hot plate is very hot right now. And just a safety check-in, just as a safety check-in, I do have goggles on. I do have my lab coat on. My hair is up. So safety protocol is being followed, and you have to wear your lab coat or apron just so you don't get your clothes messed up. Because honestly, I was doing this the other day and I forgot that I had this on. But luckily, I was wearing my safety goggles and my lab coat, because when this gets really low, you'll see the salt in there. And then the salt will actually like kind of pop out, kind of like popcorn, like little salt crystals will like pop out at you. And so I was like, oh my God. But so I actually had to like turn this off like immediately and like walk away for a second. So I didn't get hit in the face with salt crystals. So it's a good thing I was wearing my goggles, and it's a good thing I had my lab coat on so I didn't get my shirt messed up or anything like that, or get any like burns from the hot salt. So, and then I'm not working with a fire, but anytime you're heating something, you really don't want to have your hair down. So hair's up. So that's just a safety check. But while that boils, let's check in on our ink. So we're going to look at our chromatography. So this is our Sharpie and ethyl alcohol. This is our Crayola marker and ethyl alcohol. And this is our water with Crayola. Okay, so first let's look at the water with Crayola. You can kind of see some separation of color here. You can see a little bit of blue at the top and a little bit of red kind of the bottom, but there's not too much separation for the most part. It did kind of come up together. Let's look at the ethyl alcohol. So this one has awesome separation. So this kind of shows you, that's why I did a water and a ethyl alcohol to show you why we use ethyl alcohol, because it helps to separate the ink a little bit better, and the ethyl alcohol does a better job. So that's why we use that, but that's not really the point of doing this. The point of doing this is to say, okay, these red pigments, so these red dyes down here, the red dye, probably has a bigger particle size than the blue dye, which probably has a smaller particle size because it traveled farther. Remember that if there's a bigger particle size, the ink or the dye will get stuck and can't go any further because it's too big. So that's actually what happened here. So the red pigment is bigger in particle size than the blue pigment. And then let's look at our Sharpie just for comparison. And this is also an ethyl alcohol. So we know it's, doing the ethyl alcohol works really well. And so we can actually see that it's pretty much solid black ink. Maybe it has a little purple or a little blue tint, but for the most part, it's all pretty much one color. Okay, we don't have the separation of colors like we do here. So that's what that shows us. All right, so while we're waiting for our water to boil, I'm going to explain this chart so you guys get this information. So here's our chart. And our 4 different physical properties that we looked at in this demonstration were particle size, melting and boiling point, solubility, and if it was magnetic or not. And then the different examples for each are as follows. So when we filtered the bigger sand particles away from the small salt particles that were dissolved in water. So filtration separates using particle size. Same things. So like I said, when you're doing chromatography, the color that stays at the bottom is usually bigger in size, like on a molecular scale, like really tiny. You can't see it, but this is just what you can imply from looking at this, is that the red is bigger than the blue, so it doesn't travel as far up the paper. So that's another way you can physically separate on size, is chromatography. And in case you can't see, you spell chromatography CHROMATOGRAPHY, chromatography. I felt like I was in a spelling bee for a second there. And then we get to melting and boiling point, which is what we're doing right here with the water. So when you have something dissolved in something else, so for example, when you dissolve salt in water, the salt is still technically a solid, but it's just being pulled apart in really small pieces by the water, so you can't see it anymore because it's too small to see. But it is technically still a solid. It's just pulled apart by liquid water, okay? So since we have a solid salt and liquid water, we can actually boil away all the water, so we can evaporate the water, okay? And when all the water is gone, we'll have salt left over. And the reason the reason that occurs is because we have 2 different boiling points. So we have 2 different boiling points. So the salt actually boils at a really, really high temperature. So unless you made this like, I don't even know, 1,000 degrees Fahrenheit, maybe more, because salt has a really high boiling point, it would not boil. But we know that water has a boiling point of 100 degrees Celsius. So if we heat this up to 100 degrees Celsius, the salt won't boil, but the water will. So the water will go away because it has a lower boiling point, and the salt will stay because it has a higher boiling point, and it will not evaporate at this temperature. It would have to be a lot higher. Okay, so because of those differences in boiling points, we are able to separate the water from the salt, and you'll see that in a second when you can see the leftover salt. We also separated using solubility. So when we had sand and salt, we know that sand does not dissolve in water, but salt does. So when we added some water to the salt and sand mixture, the salt got dissolved and mixed in with the water, but the sand stayed there, and we were able to then filter it. So basically, sand is insoluble, so that means it doesn't dissolve, and salt is soluble. Okay, so that means it did dissolve. Okay, so after we added the water to the salt and sand mixture, the salt got dissolved and kind of went away from our vision, and the sand stayed. Okay, so we were able to separate that. And then lastly, we used the magnetic property. So we used the fact that iron is magnetic and sulfur is not. So we had 2 in that mixture, and one was magnetic, one was not. So we waved a magnet over that mixture, and we were able to attract the magnetic particles to the magnet and take those away physically. And then what was left over was the non-magnetic particles that did not stick to the magnet, and that's how we were able to separate it. Okay, so that's just kind of what I want you to put in the chart under introduction. I'm going to pause the video again, and we'll come back together when this is finished boiling, and I will show you the leftover salt. Oh, and again, I'm just going to show you really quick what this looks like. So it's just boiling. So yeah. But it does look like salt, or it does look like water, but in a second it won't. Okay, so the water is finally evaporated away, and I'm going to go and grab my hot gloves so I can show you this, because if I touch this glass, I'll burn my hand. So I put this over this so that salt wouldn't shoot everywhere. Okay, so it's not super white because I kind of burned it, but if you look closely, you can see all the salt that's remaining. So if you look closely, all the white stuff on here is salt. You can also look at the side, that is all salt. So all that's left is salt crystals. So, and that kind of like brownish powder is also salt, but like I said, I kind of burned it. Smells kind of bad, but yeah. So all that's left is salt crystals. So there's no more water. So now we've separated the water from the salt. And that is pretty much it. So hopefully you found this helpful to identify how you can separate a mixture based on its physical properties. And yeah, and hopefully you learned some safety too on wearing lab coats and stuff. But besides that, if you guys have any questions, let me know. And yeah, all right, peace.